In this session of lecture, we will be considering two parts. Initially, we will briefly go through this shunt clipper, which is used by Zener diodes, as a continuation of previous discussion where we are considering the clipper circuits with general diodes there, where we mostly considered the characteristics which was in the forward bias. But in the reverse bias, we didn't consider, because at the reverse bias, we don't like to apply the voltage to those diodes which cannot handle, because that can burn for very high reverse voltage. Now here, since we are allowed to use Zener diode, which has the characteristics like this, where it has a sharp background, where breakdown is a main thing which is there for use in Zener diode. So it is purposefully made this diode where you will be working basically in the reverse direction or reverse bias, and you will be working at the breakdown, because other than this breakdown, the current is 0 for the reverse voltage there, as you are seeing in the characteristics of Zener diode. But if you go for the forward bias, you will be seeing that this part is just like earlier diodes for which forward bias is considered. So we are not focusing much on this part, which may come in between, that one Zener diode is in forward bias. That may happen, but we are much more interested in the breakdown region. So for that, since breakdown is so important for Zener diode, I could put this few points here which we should not forget anymore. Like, it has a sharp breakdown at a particular voltage which is called breakdown voltage Vz. Now Zener diodes are generally available at different breakdown which is designed there, so that we can use that breakdown at different voltage as our reference, where we like to make a reference voltage or clip voltage somewhere. So that way it is designed, and also it has a stability in this particular voltage. Since I am saying there that it is designed for this breakdown operation, where this Vz will be so fixed there that current here which is drawn here, the slope of this will be approximately infinity. So immediately the current will go very high, which is not possible at the forward direction in the same diode, in the same Zener diode. In the forward direction, it is not possible to get that high change of current in it, but in the reverse direction at the breakdown you can get that, which is very much useful. Since I am saying it is at a fixed point or a small increment or decrement of that voltage Vz, the current will be huge there, and other than that current will be 0. So this I will call, this voltage is very much stable. That's why these 3 points are very important in terms of Zener diode, which is different from the other diodes where we don't use the reverse breakdown or don't like to apply very high voltage. So let us discuss about the clipper circuit, where we will be using 2 Zener diodes in the circuit, where we will be liking to get the clippers of biased kind of, means some biasing will be there, so that we will not get the clip at Vf but slightly higher than that. So let's see that circuit diagram where 2 Zener diodes will be used. This is the configuration what we consider for a clipper circuit, where D1 is a Zener diode with its forward voltage Vf plus minus. It has also forward voltage Vf plus minus, and it has breakdown say at Vz1, and it has reverse breakdown at Vz2 say. Now in that circuitry we are applying a voltage which has gone up to plus E to minus E, where 0 volt is the reference at the center. With respect to this, it is going plus E, it is going to minus E. Now that voltage is applied to this, where E is considered much higher than this Vf and also higher than Vf plus Vz. Either it is Vz1 or Vz2. Okay. Now let me start discussion here, where I will be equivalently incorporating the potentials which are coming across this terminal, so that I can define the output voltage V0 with respect to the input voltage Vi. So if I analyze this circuit, what minimum voltage should I need to apply here, so that one diode at least will be conducting and other diode will be non-conducting at the beginning? Because I am saying these two diodes are connected opposite to one another, one P to N, another N to P in the same circuitry. Now if I apply a positive voltage, can I say that the polarity here is plus, here minus? Maybe it is varying, but instantaneous voltage. It is a plus here, minus here. So that positive voltage has gone to this. Now to analyze individual diodes, if I consider that this voltage has gone to this diode, so this positive has gone to P side, negative has gone to N side. So it is forward biased. But here I am saying this positive side has gone to N side and negative has gone to P side. So it is reverse bias. So this diode can conduct, these two diodes can conduct simultaneously only if the voltage applied here goes beyond Vf obviously, then also beyond Vz2. Is it clear? So say some voltage has come here which has made this forward bias. So if it is forward bias, so I will be considering this forward characteristics. So in that I will be equivalently representing this part as Vf. But throughout this lecture today, you please be very much careful on the polarity which I am putting there, because this will become more crucial in the next part of this lecture. Fine. So let's start from here itself. Now if I say Vf, where is the positive part of it, positive terminal of it? Up, and here it is. So plus minus. Fine. Now it is forward biased because the voltage has gone beyond Vf. Fine, but still current is not conducting. Say this is Vf plus Vz2 and this is Vf. So I am here. So now I can say this diode maybe it is conducting, but this part is not conducting. So what is about this circuitry? So this is open. So what should be the output voltage? Not 0. Whatever be the input voltage I have applied there, that should come at the output. If somebody has some confusion how it is, because in between resistance is there, then I will ask you what current is flowing here. If circuit is open, no current is flowing, so I is 0. If I is 0, I into R1 is 0. So the potential drop here, it is 0. Now the potential here is this potential plus this potential. So 0 plus this, ultimately it is coming Vi. So the wave shape will be as like the input. Fine. Now till when? Till it reaches this point, where here the voltage will come Vf plus Vz. So in that case, this reverse bias diode will get a potential which will be breakdown. But please don't miss this point here. Here the potential which I am applying, that I am calling reverse bias. The same potential with same polarity of different value I am putting here, and that I am saying forward bias. Why it is so? Reason is that one only, because the potential is coming plus minus here. But here the configuration which is made there, the polarity is not satisfying with positive to P terminal, negative to N terminal. So, it is positive, it is negative of how much? Vz2 or beyond. Say Vz2 voltage has come there with polarity P, positive side here, negative side here. That could make this diode reverse bias, and since Vz2 is a breakdown voltage, it will start conducting. Below that it cannot. So, after it reaches Vz2, I will equivalently represent this diode with what voltage? Positive at the top or bottom? Positive at the top, because the potential Vz2 what I am applying, there is positive potential I am applying. Okay. So, it is positive, it is negative Vz2. Fine, it is just at Vz2. So, it is Vz2 and this is Vf. What will be the output voltage then now? Vf plus Vz2. So, here the output voltage I will get Vf plus Vz2. Now, beyond that, just after Vz2, why it is clipped? That is the question. Few people were asking that why this is somebody is absorbing. Don't use the word absorption here. Nobody is absorbing. It is getting clipped because of circuit condition. How? It is like this. Absorption, I do objection on that word actually. Okay. So, if it goes beyond Vf plus Vz, in that case that potential might be applied here. But what is the voltage across this? Here you are saying Vf cannot change. Here you are saying Vz2 cannot change because the characteristic says that way. It is so stable that it cannot change. So, these two voltage cannot change. So, output voltage will be always Vf plus Vz2. No objection on this? Then question can come like, if you object me to say that it is some absorption is happening, then where it is going basically? Because I am seeing that in the same circuitry I am applying higher potential, where the effect is there. Effect is that if the potential here is same, but the potential here is increasing, that is potential difference across the resistor is increasing. If it is so, current is flowing higher. If current is flowing higher there, where it is going? Again that is passing through this circuitry only. How you can say that? Because I am seeing my characteristics is like this. Whatever current you want to allow, ask to flow through the diode, it will allow, keeping its voltage fixed at the same value. This is the meaning of this particular characteristics. So, even though current is increasing because of that potential increment, but still we are concerned about the voltage across these two terminals, that is not changing. I am talking about voltage, not the current. Okay? Because I am not going to measure the current there. If some resistor would be connected here in series, then the current would come into picture. Okay? So, if it happens for this part up to this, then this portion, even though input is changing there, output will not change from Vf plus Vz2. So, it is clipped. Then just below Vz2, again it become reverse biased. So, it is open. Even though it is Vf, that hardly matters to me because circuit is open, no current is flowing there. So, output will be whatever be the input that, or it will be tracking the input wave shape. Similarly, if I go for this negative and this positive, that means negative side of this. Other side. Now, what is the change there? Only in place of plus, now it has become minus, and in place of minus, it has become plus. So, the diodes which were there in this fashion, what happened to them? Just extend the same discussion what we made earlier. Now, I will see there since it is positive, this is negative. So, my potentials will come here positive, negative here. Since it is connected to P, positive side. Again, this will be positive, this will be negative. Now, if it is below Vf of this, so it will be tracking the input wave shape till when? Till Vz1, so that this diode gets breakdown. Why I am talking about breakdown for this diode, not for this? Because I am seeing here this positive is connected to the N side and negative is connected to the P side. So, current can flow in the circuitry only if this voltage across the first diode crosses the breakdown, which is Vz1 now. Fine. So, till Vf plus Vz1, it goes, the diode will be following the input, after that it will be clipped, then again it will be tracking. Now the repetition. Okay, is it fine? Still it is not completed actually, because I have not put the polarity for this potential. What is it? Negative. Why it is negative? Because I am seeing here it is plus, here it is minus. But my convention was that positive potential will be at the output if this terminal is positive, this terminal is negative. Now, with respect to that reference, now I am seeing that polarity has got changed. So, if I want to represent the same thing in the earlier platform, I have to revert the direction, right, to revert the polarity. This is the reason with respect to which now this is negative. Fine. So, this way the circuit behaves as clipper. What is the advantage of this compared to other biased shunt clipper? In that biased shunt clipper, with a simple diode with some biasing VB1 and VB2, what we used earlier, here we don't need external sources there to incorporate. Still, we could get the clip at higher than VF voltage. Now, how it is decided? That is decided by the Zener of a particular Vz value. Now, if it changes, this level will be changing at different position for clipping. That's why I said since Zener diodes are available with different Vz, we will use that advantage there, so that we don't have to use external battery, or I will say external power source, or I will say external active device, which is the energy of source. But these diodes are obviously dead element, just like electrical elements, but those are the energy sources. I have to give energy to you. So, you could avoid that, still you could get the clip at different level. So, this is the advantage of this kind of circuitry. Now, many people may ask that I want clipping more at the positive side, less at the negative side. In that case, you will be using this D1 and D2 of different Vz value. Or if you say that the D1 and D2 which cannot be identical to one another, in that case I will say Vf values are also different. If it is so, that does not disturb the analysis what we have made there. So, in place of Vf, I will be considering Vf1 and Vf2 and Vz1 and Vz2, and I will proceed. Fundamental things are this way. Fine. With this, we are closing the discussion on diode clippers. Now, we will move to another notion of discussion, which will be diode clampers. again we will be using diodes there to discuss about this clamping circuit, which first I would like to discuss what is clamper or clamping circuit and what it basically looks like, or what purpose should we go for designing this kind of circuitry. So, basically clampers are the circuits which will able to clamp a voltage. What is clamping? Just like the doors which are clamped at the one side, so that it will be moving around it. So, it is clamped there. Like if this is the paper, this is clamped at the center now say. Now, I can clamp it at the other side also. So, if some arrangement is there for which one wave shape has come this way, that clamping was here, but I need now clamp it at the other side, not necessarily at the edge. I can clamp in between also. So, if I want to do that kind of action with a voltage waveform without disturbing its actual wave shape, those circuits will be called clamper circuits, which we are going to implement now. These are sometimes called restorer also, because it will be restoring the data without hampering its actual information which was there. Only thing is that it may change its reference voltage from one to another. Just like one voltage was there defined as going from 0 volt to plus 5 to minus 10. Now, you want to clamp it in such a way that it goes in between. That means you want to put it here at other place where this top part will be 50% of the peak to peak voltage. That means at the center. This way, for this kind of purposes, we use that. Just like for digital circuits, many people like to represent the signals like this, that if it is plus E and it is minus E, plus E is the high state, means this equivalent to state 1, and minus E is equivalent to state 0, which is a lower value. Some people may say that no, I will say 0 as the highest, and whatever may be the negative voltage, that will be the lowest. So, this is one state and another state is a 0, 1, but I have to represent by the same wave shape. In that case, you may put it down so that your reference signal moves this way. Means if it is 0 state, that means it is 0 volt, it should be minus 2E. Earlier plus E was 1, minus E was 0. Now 0 volt is one state and minus 2E is the 0 state. That can easily be used, because we want only the information which is there in it. So, without changing this, if I want to change the reference value there, that kind of action can be done by clamping circuits. So, we are for that. In that circuit, since you are saying it is a restorer where something is stored, then guess should go that if something should be stored there, then which way I will store? What is the electrical component which can store? Store means what? Information. Information is where? In terms of energy or power. So, who can store the energy? Capacitor or inductor. Without any loss of it, why not resistors? They cannot store anything. Whatever it is coming, they have to pass it immediately. So, that way resistors and reactive components, which are capacitors and inductors, are different. Okay. So, capacitors are popularly used for storing the voltage. That is why in this circuitry we will be using capacitor in it along with diode. this is the circuit arrangement which I need there. If you tell me why you have incorporated this resistor here, it may not be required because capacitor is only sufficient for that purpose what we have implemented the circuitry. Generally, sometime we use the circuitry without this R1 also, but it is more practical to consider one resistor parallel to the output, because whenever you connect something there to collect that voltage, automatically one load will be coming into picture in it. So, along with that load, expectedly or unexpectedly, that if it is coming there, why not to discuss the thing in terms of that? If it is not there, we will be considering R1 is infinity, but our remaining analysis will be as we will be taking now here. Okay. But purposefully here it is taken there because we will be discussing so many things with R1 also, which has some effect, maybe in one, not in storing, but to keep the stored thing, this has some effect there to disturb that. So, we will be coming one by one for those. As I said you, again I will remind you, please do not miss the polarity sense which will be kept there, where the potential which variation which will be applied to this circuitry is like this, where with respect to 0 volt it is going to plus E, then it is stable to that voltage, then it is going to minus E, then stable, again coming back. This wave shape will be applied there. What happens to the circuitry? We have to analyze, so that we will able to get the output voltage V0. Let us say some potential we applied here plus minus, means positive side of this wave shape. Some positive potential if it is applied there, what is the potential coming across the capacitor? Say that is Vc. Now, I have to check there this circuitry, if it is in this fashion, it is there, one voltage is applied there, whether diode is conducting or diode is open. If diode is open, R1 will be conducting. If R1 is not there, nobody will be conducting. Okay. So, say input voltage which is applied there, that has gone to this diode which has made it forward biased. It is a simple diode, not Zener. So, it has a forward voltage Vf came across it because constant voltage drop model is used there with Vf voltage. So, if it conducts, then Vf voltage will be coming here with what polarity? Plus, minus. Now, if the voltage has gone from 0 to plus E, that means plus E volt has come to the input. Some part of it has gone as Vf there to make the diode forward bias. If the diode conducts, then almost all the current, approximately I will say all the current will be flowing through this, where this R1 will be just not as a part of the circuit as if. If all the currents which are allowed to pass through a path which has resistance tends to 0, then why to face the resistive path? Current will always like to face the less resistive path, so it will be flowing through this path only. So, it is a positive potential which has come here. Now, what is the voltage across the resistor R1? Obviously Vf, because diode has the characteristics, it will keep the voltage Vf only. So, no need to worry at all about this R1. But if you want to find the current through R1, you can easily find it, Vf by R1. If Vf is very much less, of very much less value, then current is also tends to 0. Again you are verifying, fine. So, but what is the Vc value then? If this is the total potential applied here, positive here, negative here, what is the polarity here? Positive here, negative here. Then, if it is positive here, negative here, what is the potential across the Vc? E minus Vf. Because I know the Kirchhoff's voltage law where the potential across this will be equal to the total potential gone to the other part. So, E is equals to Vc plus Vf, or Vc is equals to E minus Vf, but where is the polarity? Plus here, minus here. Okay. So, output voltage is till this position, input voltage is plus E, Vc is E minus Vf. What is the potential here then? From here to here as output, you are saying it is Vf. You are saying it is Vf. So, this part is at Vf. Fine. Now, after you come to this point, suddenly the voltage is going from plus E to minus E. That means the polarity here is getting changed to minus to plus. Earlier it was plus E, now it has become minus E. How to track? I will put the polarity minus here, plus here immediately. So, I have to focus on this now. What is about the capacitor? What is the polarity of the Vc? Which side is the positive, which side is the negative? One characteristic I will tell here of a capacitor. Capacitor cannot change its voltage immediately. It can change current, but it cannot change the voltage immediately. So, at that instant when it has gone to plus E to minus E, that is why repeatedly I was saying that immediately at that time when it has gone to plus to minus E, immediately if you see the potential across here has become minus E, means with negative here, positive here, but at the capacitor it is still Vc with polarity plus here, minus here. Okay. Now, what is about this diode? Is it conducting? If this is positive, then it has gone to the end side. If this is negative, it has gone to this side. So, it is open. But what is about the output voltage? Again KVL, voltage law. The voltage across this, if I want to see, I will like to see where are the drops has gone. I will add them. I am saying here is the drop. How much? Vf, obviously minus. I will come to that point. Sorry, Vc. Vc value is there. Vc potential here and E potential is there. So, the output voltage V naught will be minus E minus Vc. Why minus and why minus E or why minus C? Do not say that I am seeing it is negative and it is positive. Again you should remember, I said you, I am defining the polarity with respect to positive here, negative here. So, with respect to that I am seeing here the polarity has become negative, here positive, and finally here negative, here positive. Ultimately, if I see from here to here, it is actually negative, two negative voltages are added there. So, the effect of this is negative, positive, which has gone to this place, which is in the other sign of our convention, what we have taken at the beginning as positive voltage. So, it should be minus of that. Okay. It is E minus Vc. Now, put the value of Vc of earlier one. So, it is becoming, I think it is becoming minus E plus Vf. Or I will say minus 2E minus Vf. Fine. So, if the voltage I have to plot at the output side, I will be getting same shape like this, where it will be giving the wave shape this way, where this voltage will be how much? Minus 2E minus Vf. Okay. Now, immediately after that, if it repeats, then same thing will happen like earlier. It will be going up to this, then again Vf this way. But since I have shown here up to this, so it will be again coming up to 0. Our job is finished. Okay. So now, if this wave shape was there where with respect to 0 volt, it went up to plus E and up to minus E at the bottom side. In this, where from it has started and where it has gone with respect to again 0 volt, it went to Vf, then it went up to E minus Vf, 2E minus Vf. Why that minus Vf is coming? Because you are taking Vf here. Okay. But here I was seeing that total was 2E, peak to peak. VO, peak to peak. If I say earlier it was 2E, is it now 2E? It has to be, otherwise it is not clamper circuit. Because definition I have given like that, without disturbing anything, I have to make it done. So, what is the potential difference between the peak, upper peak and the lower peak? So, Vf minus of minus 2E minus Vf, minus 2E minus Vf, this is the peak to peak voltage. If you find there, I think it is coming to E. Okay. So, if in terms of wave shape, if I say it is exactly same, but if I say in terms of clamping, earlier it was clamped in such a way, positive side will be going up to plus E and negative side up to minus E. Now, in this, it is going clipped up to plus Vf and it is clipped up to minus 2E minus Vf. In between, if I use another circuitry where I want the clipping up, in that case I will make the circuit and like some biasing will be made there, so that it will be going up, or I will use some circuitry there where this Vf will be 0. If Vf is 0, what is the peak here? Minus 2E. So, it has gone to the top. So, this way this leveling of or the platform with respect to which I want the wave shape to go up and down, that can be controlled by which? By this circuitry. Yes. If we, okay, good. He is asking that if I make the diode connected in reverse direction, our connection was this way. So, for that the output what we got here, that is presented here. Okay. Since the clamping here is made at the negative side, ideally speaking, if Vf is 0, then it has gone down, it has gone up to minus 2E, everything is the negative side, so it is named as negative voltage clipper. But if I want the opposite action here, I want to push it to the positive side, I will be going for positive voltage clipper. In that case, I will be reverting this diode. This is for positive voltage clipping circuit. Okay. I wanted to come to that discussion after this, but it is now done. Okay. So, the same kind of analysis again you will do for this diode arrangement where things are exactly same, other than this diode forward biasness and reverse biasness. Okay. But we will discuss now about more important point which will be involved here. Just like if I have made the thing done this way, where this voltage was here Vc with this potential in which the diode was reverse biased like this, so that we could get the V naught in this fashion, how long it will be there? How long that wave shape will be there? Now, think about any current flow in the circuitry, because diode is not in the picture. If diode would be there, you will be influencing others. But diode is not at all there, since it is reverse biased and it has gone open circuited, and as if it is not there, so remaining circuitry are existing with this R1. So, some potential is there applied across this circuitry where the loop is complete. If one battery is open, nothing will flow there, but if the time you close positive to negative terminal through some element, current will start flowing, as if that source is connected with one capacitor and one resistor which are close to one another. Now, in between, if I break the circuit, then nothing. But since the existing circuit is this way, so I am seeing one closed path is there where current is flowing. Okay? So, if it happens, then some current is flowing through the capacitor. Obviously, through the resistor also. Some current, if it is flowing through R there as IR1, how much it is? Simply, the voltage across the resistor divided by the resistance. How much is the voltage across the resistor? Approximately it is 2E. Because the potential difference from positive to negative has gone from here to here. Now, if you consider this time for which this width was so small, this time is very, very less. In that case, you can consider this is the current, this is the potential difference which is throughout, or the potential difference for this one, the current flow through the resistance is say constant. In that case, if some current is flowing through it, I R1 square R1 loss is there. Not only that, earlier you were driving this capacitor with a potential where positive here, negative here. That's why this was getting charged with positive this side, negative this side. Now you are charging it in other way. So you are actually forcing it to get positive charges accumulated here and negative in the other side, because you are dominating on it with another potential where E may be much greater than the earlier Vc what you stored there. If it happens, so it is actually forcing. Okay, but since in the capacitor the voltage cannot change immediately, but current can, we should not analyze the circuit where capacitor is involved in terms of voltage, but we will discuss in terms of difference of voltage with respect to time, or in terms of current through it, or the continuity equation of a capacitor. I hope you might have heard the term continuity equation of a capacitor, through which we will be finding the current through IC, means current through the capacitor, which is same as IR in this place. So if IR is the current which is flowing through the capacitor, now capacitor current, we knew that it is C1 D Vc delta Vc delta T. Is it fine? Current through a capacitor is rate of change of the voltage in it multiplied with the capacity of it. Okay. So, delta Vc can be written as IC into delta T by C1. Now say this T is very small, where T is delta T only. This T is very small, for that the delta C Vc I am defining as IC into T by C1. I think it is fine. Okay. Now, to know delta Vc for delta Vc means what? Change of voltage across the capacitor. At what time? Delta t or t. That means the time for which the capacitor was supposed to keep the voltage. So, that is not allowed because one resistor is there through which it is getting discharged and it is slowly going down. So, the voltage here which I plotted in this fashion, it is not exactly. So, by this time it has gone this way. So, this much delta Vc will be there. So, actually the wave shape will become distorted this way. If it is so, it could not restore the wave shape, it will be deviating. Okay. Even though you do not connect any load there, any R1 there, still because of the load connected to the circuitry, that will behave like this and that will drag you down. Okay. So, that is why this kind of resistance is considered here, so that we get some idea about if the pulse width of this is of finite length, finite width, in that case how much is the delta Vc can happen in it. Okay. So, in that case, if I want to know this, T is known, C1 is known, now I have to know IC or IR into T by C1, because IC is again IR1, because the same current is flowing there. Now tell me, what is IR1? If I say the voltage here is 2E, so the potential difference is 2E divided by R1. So, that value if I put there, so what delta Vc you are getting? Very, very much important one concept will come out from there. R1 C1 is called time constant, which is sometimes denoted as tau with unit second. That means ohm into farad or microfarad, it is unit of second only or time only. Okay? So, if R1 and C1 is there, where I am seeing in this particular wave shape, this 2E is the potential which has gone up higher value to the lowest value, which is defined for a wave shape, and the width of the wave is also defined there. So, this 2E and T, these are defined by the wave shape which you are applying to the circuitry, but you have devised the circuit using one C and one R there. So, they are involved in this fashion. So, if you want lesser and lesser delta Vc value, you have to choose this C1 and R1 such that delta Vc become less. That means, if you want lesser delta Vc, R1 and C1 should be, R1 into C1 tau should be higher and higher. Okay. How I can do that? By just taking the value of R and C such that it becomes high. But why it is named time constant? This is the question. This is the time constant by which it is defined that at what rate the voltage will get changed through it. Say, voltage is trying to get changed, but in which manner? By flowing through the resistor and capacitor. Now, the resistor has its own inherent behavior that it will be resisting to do that. So, if you increase the resistor, it will not able to do that. Philosophy I am talking about. It will be resisting to flow. If it resists to flow, then this voltage drop will not able to happen. Okay. That is why if you increase R1, R1 C1 increases, time constant increases, and finally delta Vc decreases. So, time constant basically is a response time also, that how quick it will be responding. That if you want to restrict, that can be controlled by time constant, which is defined by simply resistor and capacitor connected through it. Okay. So, slowly during this time it will be discharging. Does not it happen if when I charge, in that case if some resistance is there into it, that may restrict to charge? That is also another phenomena. We have to go for that also. If some resistance come in the circuit, in the same circuit where through charging some resistance come there, then how it affects? Say in this another resistance, if it would be connected, scenario would be different. Since R2 is equals to 0, what is the time constant there? R2 into C1 could be 0. If it is 0, then immediately it will be going, or in other way I will say nobody is there to resist to do me whatever I am asking to do. Okay. So, this is the reason the time constant is coming into picture in this circuitry, where we want to store the actual waveform, but we may deviate from it. So, we should know the system specification also, which way to design. We will discuss that in the next class. Thank you.